Hello children. In this lecture, in this video, we work out the sums based on the topic on area under the curve and differential equations. To start with the first problem, area of the region bounded by the parabola y square equals 4ax and the latest rectum. Y square equals 4ax and the latest rectum. Of course, this is nothing but actually, if you could remember, then you can use a direct formula. It is 8a square by 3. It is a direct formula. Okay, this option is C. Otherwise, you can say y square is equals to 4ax. So y is equals to 2 root a root x, and this is actually the parabola and this is the latest rectum. This is the latest rectum. The focus is a comma 0. Therefore, the area is this one. Now we'd like to calculate it is from 0 to a above the x-axis twice of it. Twice 0 to a fy dx 2 root a root x dx, and that is equals to 4 root a multiplied by x root x, okay, into 2 by 3. The limits are from 0 to a. 0 to a. And when you substitute the value 8 by 3 root a multiplied by a root a, therefore 8a square by 3. That's answer. So 8a square by 3 answer for this one. Coming to the second one, area of the region bounded by the parabola y square is equals to minus of x minus 4, okay, and y-axis. X minus 4 and y-axis. So y square is equals to minus of x minus 4. Y square is equals to 4 minus x. Clearly, x equals to 0, y is equals to plus or minus 2, and y is equals to 0, x is equals to 4. And this is the parabola, looks like this one, therefore it is like this. 4 comma 0 minus 0 comma minus 2 and 0 comma plus 2, and therefore the area is given by nothing but 0 to 4. You can calculate upper value and then multiply by twice of it. So because of the symmetry, so the required area is equals to twice of integral 0 to 4, starting from here to here, 0 to 4 under the curve. The curve is nothing but root of 4 minus x dx. Root x derivative 2 by 3. 2 multiply by 2 by 3 under root multiply by, yes, of course, 4 minus x. So 4 minus x to the power of 3 by 2 with minus sign by minus 1. The limits are from 0 to 4. And therefore, substituting, I think 4 by 3 multiplied by 4, substituting, you'll be getting minus 4 by 3, 0 minus, you get it 4 power 3 by 2 is nothing but 2, okay, 4 root 4, nothing but 8. So the answer is equal to minus minus plus 32 divided by 3. So the answer for this problem is equal to 32 by 3. Coming to the next one, area enclosed between the two curves. Y square is equals to 4ax and x square is equals to 4by. Here is the formula. Y square is equals to 4ax and x square is equals to 4by. The area bounded by the two curves is nothing but 16ab divided by 3. So in this case, y square is equals to 6x. And x square is equals to 4y. X square equals to 4y. So the 4a is equals to 6. This can be written as 4a multiplied by 4b divided by 3. 4a value is equals to 6 and 4b value is equals to 4 by 3. So therefore 3 2, so the answer is equals to 8. B is equals to 116ab by 3. 16ab by 3. So the answer is equals to 8. Yes, first option A. Coming to the next one, area enclosed by the parabola x-axis between the lines x equals 0 to x equals to 3. Y is equal to 3x minus x square. Y equals to 3x minus x square. Okay, and x-axis y is equal to 0. So when you solve these two, it is, the curve, the parabola is intersecting x-axis at the points x multiplied by 3 minus x is 0. Therefore, x equals 0, x is equals to 3, and x square coefficient is negative. It is inverted parabola like this. And this is actually the region 0 to 3 we require to evaluate. So therefore, area x equals to 0 to 3, area under this curve is nothing but integral 0 to 3 y dx, 3x minus x square dx. And that is equals to 3x square by 2 minus x cube by 3, limits from 0 to 3. Yes, of course. 0 substitution. 0, 3 means 3 3s are 9 3s are 27 by 2 minus 27 by 3. So 27 multiplied by 1 by 6. So 3 9s, 3 3s, 3 2s. So the answer is equals to 9 by 2. So the answer is 9 by 2, the first one. Coming to the next one, the area between the hyperbola x-axis and the ordinates x equals a to x equals to b, where a is greater than b. Let me consider xy is equals to c square. Xy is equals to c square is hyperbola. It looks like this one. This is the curve, and x is equals to a to x is equals to b, we need to consider. So assuming that both a comma b are positive, x equals a to x is equals to b, area under this values. So now let me consider here a is equals to integration a to b y dx, c square by x dx. That is equal to c square multiplied by log x between a to b, and therefore c square multiplied by log b minus log a. Therefore c square multiplied by log b by log a. So the answer is c square log b by log a. Okay. Now coming to the next one. Area bounded by the curve x equals to 1, x equals to 3, xy is equals to 1, and x-axis similar to the previous one. So xy is equals to 1, x equals to 1 to x equals to 3, and the x-axis and x-axis. And therefore, this is actually the hyperbola. You get it like this, x equals to 1 to x equals to 3. So area is equals to integration from 1 to 3, 1 by x dx. That is equals to log x limits from 1 to 3, log 3 minus log 1. Log 1 is 0, so answer is equals to log 3. So answer is log 3. So B option. Coming to next one, 7th one. The area bounded by. Yes. Now the areas of the figure. The areas of the figure into which the curve divides the circle in the ratio. This is a bit calculative. So let me take up here. Y square is equal to 6x, x square plus y square is equal to 16. So y square is equals to 6x and x square plus y square is equals to 16. Yes. So one is a circle, another one is the parabola. So therefore, the parabola is dividing the region of the circle into two parts. So it is x-axis and this is y-axis, and this is actually the parabola, and therefore this is one portion and this is the remaining portion. So we need to find the ratio of these two areas. So to evaluate, let me calculate what is this point, this particular area, the upper portion of this. So circle and the parabola. So let me calculate here actually this portion. So that make it double, that gives you the area bounded by this one, and then remaining portion you can calculate. So let me evaluate this one by solving these two equations. You will be getting it as x square plus 6x minus 16 is equals to 0. Therefore, x minus 2 multiplied by x plus 8 is equal to 0. So, x cannot be negative. So, x is equals to 2. That means x equals to 0 to x equals to 2. And radius of the circle is equals to 4. This is x is equals to 4, right? And therefore, this is nothing but the region area under this parabola, area under the circle. And therefore, it is area is equals to twice. Total area is nothing but the twice integration 0 to 2 under the parabola. Parabola is root 6 root x. Plus under the circle is nothing but integration 2 to 4. 2 to 4 under root of 16 minus x square dx. And on simplifying this one, that is equals to root 6 multiplied by, it is twice. Later we multiply this one. So we'll see that twice of root 6 multiplied by 2 by 3 x root x limits from 0 to 2 plus x by 2 multiplied by root of 16 minus x square plus a square by 2, that is nothing but 8 sine inverse x by a. So therefore x by 4, limits from 0 to 4. Overall, this is answered. That is equals to twice of the calculations of 2 when you substitute. It is 2 by 3 multiplied by 2 into root 2. So therefore root 6, root 3. So this value simplifying 6 multiplied by 2 root 12, 2 2s are 4 by 3. 4 by 3 times of root 12. Yes, 2 into 2, 4 by 3. Root 6 multiplied by root 2, root 12. Minus 0, plus. And this is from 2 to 4. So 4 when you substitute, I think it is 0. And sine inverse 4 by 4, 8 pi by 2. Plus 8 pi by 2. Minus root 12. 2 when you substitute, I think 2 gets cancelled, will be getting a root 12, and sine inverse of half is nothing but pi by 6, minus 8 pi by 6. That on simplification, it is twice. The value of this is a 4 by 3 root 12 minus root 12 is nothing but actually root 12, 1/3 of root 12 plus 8 pi by 2 minus 8 pi by 6. I hope we'll be getting 3 minus 1, 2 by 6, 8 pi by 3 plus 8 pi by 3. Overall, when you multiply, I hope we'll be getting it as 2 plus 6, 2 root 12. Root 12 can be written as 2 root 3. 4 root 3. So you will be getting 4 root 3 plus 16 pi divided by 3. So 4 root 3 plus 16 pi by 3. This is the value. So the area of this particular region is given by 4 root 3 plus 16 by 3. But the remaining portion is nothing but area of the circle. That is nothing but pi r square. Pi r square means 16 pi minus of this value. So the remaining portion can be written as, I will rewrite here because I don't have place. So therefore, the remaining portion is nothing but 16 pi minus of 4 root 3 plus 16 pi by 3. So 16 pi by 3. So that will be getting it as a 32 pi. 32 pi minus 4 root 3 by 3. Now the ratio of these two, when you take up, I hope you will be getting it as a 4 root 3. Okay, 16 pi plus 4 root 3 divided by 32 pi minus 4 root 3. And simplifying this one, I hope a cancellation of 4 pi plus root 3 divided by 8 pi minus root 3. 4 pi plus root 3 divided by 8 pi minus root 3. Yes. Sorry, this one. So the answer is equals to C. Yes. Coming to the next one, area bounded by normal at 1, 2 to the parabola, x-axis and the curve is given by how much? Area bounded by the curve, normal to the curve, y square is equals to 4ax. Yes. So the curve is y square is equals to 4x, x-axis, and the normal at point 1, 2. Normal at point 1 comma 2. To calculate normal, let us find out the equation of the normal. So this is actually the parabola, looks like this one. The normal at 1 comma 2 is nothing but this one. So definitely the area is nothing but actually area. When you take up here the perpendicular here, x is equals to 1, and this is we do not know what is this coordinate. Let me calculate. The derivative of this one is 2y y dash is equals to 4. Y dash at the point P is equals to 4 divided by 2y. 2y, y coordinate is 2, therefore 2 2s are 4, that is equals to 1. This is the slope of normal. So sorry, slope of the tangent. Slope of normal. The slope of normal is equals to minus 1. Then equation of normal at point P is given by y minus 2 equals to minus 1 into x minus 1. And that point of intersection with the x-axis is given by, so minus 2 is equals to minus x plus 1. So x is equals to 3. So this coordinates equals to 3. And of course, since it is 1 comma 2, height is equals to 2. Therefore, let me write down this parabola clearly. Therefore, this is the parabola and this is the point and the normal is drawn, and therefore this is a 3 and this is a 1. Of course, this length is equals to height is equals to 2. You know, this is area of the triangle. Enough you calculate this area and this one you have to calculate. So therefore, this area is between x equals 0 to x equals to 1. This area, okay, starting from 0 to 1. So integral 0 to 1 area under the curve y square is equals 4x means 2 root x dx. That equals to 2 multiplied by 2 by 3 x root x between 0 to 1. 1 if you substitute, you'll be getting 4 by 3 area. So this is area 4 by 3 plus the area of this triangle, half into the base length is 2, height length is equals to 2. So therefore, I'm simplifying this one, 4 by 3 plus 2. How much will be getting? 10 by 3. So the 10 by 3 is the required answer here. Yes, the first option. Coming to next one, the value of A for which the area of the region bounded by the curve and the straight line x equals 0 to A and x-axis is given by. Yes, of course, and x is equals to 0, I hope it is 0 passing through origin, x equals A, assuming A is positive, this is a positive value. So therefore, it is something curve y is equals to 8x, y equals 8x square minus x power 5, 8x square minus x to the power of 5. So definitely this is nothing but a curve which is something which is passing through origin, something like this, and x equals 0 to x equals to A. And that area is nothing but actually it is integration 0 to A y dx, 8x square minus x to the power of 5 into dx. And that area is given by 16 by 3. That equals to 16 by 3. We need to evaluate how much is that 16, A value. Let me simplify this one. It is 8x cube divided by 3 minus x power 6 by 6. And limits from 0 to A is equals to 16 by 3. A when you substitute, I hope you'll be getting 8a cube minus a power 6. 8a cube by 3 by 6 is equals to 16 by 3. Cancellation of by 6, you'll be getting 16a cube minus a power 6 is equals to 32. So this can be written as a cube taken whole square minus 16 times of a cube plus 64 is equals to 0. Because 32 plus 64 is equals to, okay, plus 32 is equals to 0. Yes, of course. I hope we can make it a perfect square. A cube whole square minus 16a cube plus 8 2s, 64 is equals to 32. So that on simplifying, a cube minus 1 minus 8 taken whole square is equals to 32. So therefore a cube is equals to 8 plus 8 plus 4 root 2. And therefore a must be equals to a plus 4 root 2 to the power of 1 by 3. So a must be equals to, so 8 plus 4 root 2 to the power of 1 by 3. So the answer is equals 8 plus 4 root 2, 8 or 8 minus. Yeah, I hope because square root may be plus or minus. So one of the value you can take it as 8 minus 4 root 2 also. So therefore, you can have 8 minus 4 root 2 power 1 by 3 is existing it. So answer is A. Coming to the next one, area enclosed between the curves y equals x cube and y equals root x. Yes, clearly you can see that y is equals to x cube curve looks like this one. Y equals root x curve like this one. This is root x, y equals x cube. Both of them intersect at point 1. So area between the curves between 0 to 1. Upper curve is root x, lower curve is x cube. Therefore, area is equals to integral 0 to 1 upper curve root x minus x cube into dx. Therefore, this is 2 by 3 x root x minus x power 4 by 4 limits from 0 to 1. So therefore, yes. So therefore, substituting 1, I hope we'll be getting 2 by 3 minus 1 by 4. I hope we'll be getting 8 minus 3, 5 by 12. The answer for this one is equals to 5 by 12. So C option. Coming to the next one, the area bounded by sine inverse x and the x is equals to 1 by root 2 x axis. Sine inverse x graph. This is actually the sine inverse x graph. It looks like this one. Sine inverse x graph. X is equals to, here it is 1. 1 by root 2 comes somewhere here. X is equals to 1 by root 2. Yes, x is equals to 1 by root 2. This is actually the region which is bounded by the curves here. X is equals to 1 by root 2, x-axis and the curve. Okay, let me calculate that. It is from 0 to 1 by root 2. 0 to 1 by root 2 under the curve sine inverse of x dx. How much is the value? We know by basic of fundamental integration, integral f of x dx can be written as x f of x minus integral x into f dash of x dx. By parts concept, I say that it is nothing but x sine inverse x limits from 0 to 1 by root 2 minus integral x derivative is 1 sine inverse x. Yes, of course, x sine inverse x, x divided by root of 1 minus x square dx limits from 0 to 1 by root 2. So 1 by root 2 multiplied by pi by 4 minus, this is x by root of 1 minus x square. Integration is minus root of 1 minus x square limits from 0 to 1 by root 2. And that on substitution pi by 4 root 2 plus 1 by root 2 when you substitute you'll be getting 1 by 2 half will be getting 1 by root 2 minus 1. So the answer for this problem is 1 by root 2 plus 1. I hope you'll be getting plus minus. Yes, answer is fourth option. D. Coming to the next one, area bounded by y is equals to tan inverse x and x equals to 1 and x axis. Y is equals to tan inverse x and x axis and x is equals to 1. Y equals to tan inverse x graph looks like this one up to pi by 2 and x is equals to 1 somewhere here, get it? X is equals to 1 and x axis from x equals to 0. So therefore it is nothing but integral 0 to 1. It is a tan inverse x dx. Same as the previous formula. X tan inverse of x limits from 0 to 1 minus 0 to 1 x divided by 1 plus x square, derivative of tan inverse x. And that is equals to x tan inverse x minus this is half log of 1 plus x square. Denominator f dash by f model. So limits from 0 to 1. Lower limit value is 0, automatically everything 0. 1 if you substitute tan inverse 1 is equals to pi by 4 minus half log 2 and that of course so pi by 4 half log 2 means I hope you can rewrite this one as a pi by 4 and minus half or plus minus of log root 2 you can say that. pi by 4 minus log root 2. Yes, of course, B option answer. Coming to 13th one, limit of a sum. As I told you last class that limit n tends to infinity 1 by n sigma function of r by n, where r runs with 0 to kn can be replaced by 0 to k phi of x dx. This is the formula. So it is r runs from 1 to 2n is given to you. It is the limit n tends to infinity 1 by n sigma r is equals to 1 to 2n. It is r divided by root of r square plus n square plus r square. Yeah, numerator denominator divide by n. Limit n tends to infinity 1 by n sigma r equals to 1 to 2n. It is r by n. When you divide by n, it is 1 plus r by n taken whole square. And this is completely function of r by n 1 to 2n. Therefore, you can replace it by 0 to 2 and r by n replaced by x divided by root of 1 plus x square dx. And this is actually the derivative of root of 1 plus x square, limits from 0 to 2. Substituting, I hope we'll be getting root 5 minus 1. So answer is equals to root 5 minus 1, B option. Coming to the next one, yes. And this also, there is a simple formula. You remember this one? It is a limit n tends to infinity n sigma n to the power of k divided by n to the power of k plus 1. The answer for this one is equals to 1 by k plus 1. Remember this way? It's very easy to simplify the problem in the game. But here, in this case, you have 2 power k, 4 power k, 6 power k. Why didn't you take a 2 power k common? So it is a limit n tends to infinity 2 power k when you take up common 1 power k, 2 power k plus and so on n to the power of k divided by n to the power of k plus 1. N to the power of k plus 1. Why didn't you take out the common here? It is limit n tends to infinity 2 power k into sigma n to the power of k by n power k plus 1. So the answer is equals to 2 power k divided by k plus 1. So the answer is equals to 2 power k by k plus 1. Coming to the next one, area enclosed between the parabola and the straight line. Now, actually, when you take up the parabola and the straight line, area bounded by parabola and the straight line. So let me take up y is equals to x square minus x plus 2, the parabola, and the straight line y is equals to x plus 2. Remember one pointer, when a parabola and a straight line are given to you, okay, when you just solve them, I'll be getting it x square minus 2x. Yes, subtracting it, x square minus 2x equals 0, x is equals 0, 2. And this is a parabola and the straight line, both of them are intersecting at 2 points, x equals 0 and x equals 2. So 0 to 2. And area bounded by these two curves, straight line minus the parabola. So therefore, area is nothing but a straight line minus parabola. So 0 to 2, x plus 2 minus of x square plus x minus 2. Yes, into dx. Yes, of course, here 2 gets cancelled, minus x square minus 2. And that is equals to minus x cube by 3 plus 2x means x square, limits from 0 to 2. So minus 8 by 3 plus 4, that is equals to 4 by 3. So the answer is equals to 4 by 3. Yes, correct. Coming to the next one, area enclosed, area of the closed figure bounded by x is equals to 1, minus 1, x equals to 2, and y is equals x square minus 2, x square minus x square plus 2 for x less than or equals to 1, and 2x minus 1 for x greater than 1. Okay, y is equals to, you are given y is equals to minus x square plus 2 for x greater than or equals to 1. Sorry, less than or equals to 1. x less than or equals to 1, and 2x minus 1, 2x minus 1 for x greater than 1. Isn't it a parabola? And you're required to calculate x equals to minus 1 to 2. X equals to minus 1, x equals to 2. So the total region when you take up, let's say that x equals to minus 1, x equals 0, x equals to 1, x equals to 2. Okay, at minus 1, when you substitute x is for x less than or equals to minus 1, 1 is substitute, you are going to have 1. X equals to 0, it is equals to 2. Yes, of course. And x equals to 1, again it is 1 now. So this is nothing but actually the parabola, inverted parabola. It looks like this one, and it is by symmetry. You'll be getting x equals to 0, and therefore x equals to 0, and after 1, after 1 x is equals to 2 when you substitute 4 minus 1, 3. So it is 2 and 3. This is a straight line now. So now we require to calculate the area here to here and this one. This is nothing but actually area when you drop here the perpendicular, because this height is 1, length is 1, this is a square area, and this height is equals to, and as it is a 3 and this is 1, and therefore height is equals to 2. We can calculate area of this square, it is 1, and this is half into base into height. We can also calculate. Now enough if you calculate area under this parabola, this particular area. Now let me calculate minus 1 to plus 1. And by the symmetry of this one, minus x square plus 2. Integral minus 1 to 1 minus x square plus 2 dx. But here when you take up f of minus x is same as f of x, I would say that it is twice integral 0 to 1 2 minus x square dx. And that is equals to 2 times 2x minus x cube by 3, limits from 0 to 1. And when you substitute 1, will be getting 2 minus 1 by 3. And 5 by 3, 5 2s are 10 by 3. So this area is nothing but 10 by 3. So it is 10 by 3 plus area of the square is equals to 1 plus area of the triangle is nothing but half into base into height, that is also 1. And of course this is 10 by 3 plus 2. So how much you'll be getting? 6 plus 10, 16 by 3. So the answer is equals to 16 by 3. Yes, correct. Coming to the next one, area of the rhombus enclosed by the straight lines. Area of the rhombus enclosed by the straight lines, ax plus by plus r minus by plus r minus c is equal to 0. Ax plus r minus by plus r minus c is equal to 0. It is nothing but area enclosed by the straight line, means nothing but rhombus. And of course this is a line is nothing but ax plus by plus c is equals to 0. Putting in the intercept form, this x-intercept, x divided by minus c by a, y divided by minus c by b is equals to 1. You got x-intercept and y-intercept is nothing but half into base into height. Area of this particular part is nothing but half into c by a multiplied by c by b. And that is equal to c square by 2 modulus ab. And of course, total area is nothing but 4 times of this one. So 4 times c square divided by 2 times mod ab. That is equal to 2c square by modulus of ab is the required answer. C square, 2c square divided by ab. That's right. Coming to next one. The maximum area of the rectangle whose 2 vertices lies on x-axis and 2 on the curve y is equals to 3 minus modulus x, where x lies between minus 3 and plus 3. See, y is equals to 3 minus modulus x. Y is equals to 0, x is equals to plus or minus 3. And x equals 0, y is equals to 3. These are nothing but actually the straight line. It looks like this one. So therefore, when I take up, this is 1, 2, 3, 1, 2, 3. Therefore, this is the point 1, 2, 3. So therefore, this is one straight line. This is another straight line. Yes, this is y is equals to 3 minus modulus x. And you require to find out the area of maximum area of the rectangle. You require to construct a rectangle whose 2 vertices lies on x-axis and 2 on the curve. That means you have to construct a curve like, the rectangle like this. Let me assume that this is 0, this length is equals to x, and definitely this equation is nothing but when it is x, when you substitute y value is equals to 3 minus x. Y must be is equals to 3 minus x. So therefore, this is y 3 minus x, this is x, and area of this rectangle is length into breadth. The length is x and the breadth is 3 minus x, and twice of it is a total area, and that is nothing but area of the rectangle. And therefore, area of the rectangle is equals to 2 times 3x minus x square, and this area has to be the maximum. Maximum only when the derivative is equal to 0, you get stationary point. So a dash is equals to twice 3 minus 2x, that is equal to 0, gives us x equals to 3 by 2. At this point x equals to 3 by 2, area will be the maximum. So the maximum area is equals to given by, it is 2 into x, that is 3 by 2, multiplied by 3 minus 3 by 2 is 3 by 2. So you will be getting 9 by 2. So the answer is equals to 9 by 2. None of these? Yes, 9 by 2. Okay, coming to the next one. The area of the region bounded by the parabola y square is equals 4ax and the lines x equals a and x equals to 4a. Area of the region bounded by the parabola and the lines x equals a, x equals to 4a. Y square is equals to 4ax. Let me take up. Y square is equals to 4ax, x equals to a, and x is equals to 4a. Okay, let me take up here. This is actually the parabola. X equals a, x equals to 4a. That is nothing but this area. Now by symmetry we can take it as above the x-axis starting from a to 4a, and we calculate double of it. So the required area is equals to twice integral from a to 4a. Under the curve it is 2 root a root x. That is equals to 4 root a multiplied by 2 by 3 x root x, limits from a to 4a. Okay, that is 8 root 3 root a by 3. 8 root a by 3 multiplied by 4a. So 4a multiplied by 2 root a minus a root a. And that on simplification 8 minus 1. 4 2s are 8 minus 1, 7. 7 8s are 56. Yeah, 56. Okay, this is 7. 8 root a by 3 multiplied by 7 times a root a. That is equals to 56a square. I think it is a in multiplied by a, 56a square by 3. So let me, yes, correct. 56a square by 3. Coming to the next one, area bounded by the curves y square is equals to x and x square is equals to y. I think I told you already formula. Y square equals x, x square is equals to y. And therefore, y square is equals to 4ax, x square is equals to 4by. So 4by. So 4a is equals to 1, 4b is equals to 1. Area bounded by these two curves is given by 16ab by 3. That's nothing but 4a multiplied by 4b by 3 if we can write. And that is equals to 1 by 3 answer. So the answer for the problem is equals to 1 by 3. Coming to the next one. Area bounded by the curve and x-axis. Similar problem we have done it already. So therefore let us see that y is equals to 2x minus x square and x-axis y is equal 0. And therefore solving these two, you'll be getting 2 multiplied by, I hope you'll be getting 1 minus x multiplied by x is 0. So x is equals to 0, x is equals to 2. Sorry. X equals to 2. Therefore, this is nothing but actually the parabola looks like this one. So, the area is given by, it is integral 0 to 2, 2x minus x square dx. And that is equals to x square minus x cube by 3, limits from 0 to 2. So, 4 minus 8 by 3. 12 minus 8 is 4 by 3. So, the answer is equals to 4 by 3. Yeah, I think it is 1 by 3. It's 4 by 3 answer. Yes, correct. Coming to the next one, area enclosed between the parabola and the line. X square is equals to 4y. x square is equals to 4y, and x is equals to 4y minus 2. X equals to 4y minus 2. And these are the two curves given to you. Y square is equals to, yes, of course, this is actually the parabola. Y square, x square is equals 4y, and this is nothing but actually a straight line, and both of them, they do intersect at 2 points. Let's see their point of intersection. X square minus x plus 2 means minus x minus 2 0. So therefore x minus 2 multiplied by x plus 1 0, and therefore x equals to minus 1, x equals to plus 2. Minus 1 to plus 2, x equals to minus 1 to 2. So area is given by minus 1 to 2, area under the straight line minus area under the curve. The straight line is given by, so from here 4y, x equals to 4y minus 2 means x plus 2 by 4 is equals to y, and therefore x plus 2 divided by 4 minus from the curve. So that is, from this curve you'll be getting y is equals to x square by 4, nothing but x square by 4 dx. 1 by 4 taken common and simplifying it to 1 by 4 times x square by 2 plus 2x minus x cube by 3, limits from minus 1 to 2. And by substituting this value and simplifying, you get a required answer. So let me check once the value. How much is this one? So 1 by 4 times 2, when you substitute 4 by 2, 2, and 2 2s are 4, minus 8 by 3, and minus 1, when you substitute 1 by 2, minus 2, minus plus 1 by 3. And let me calculate, I think it is a 6 here. 18 minus 8, 10 by 3, I'll write here. So 1 by 4 times 10 by 3, and minus, yes, of course, this value 1 by 2, 5 by 6. So 3 plus 2, 5 by 6, minus 2, 12, minus 5, minus 7, plus 7 by 6. 20 plus 7, 27 by 27, right? So 3 2s, 27 divided by 4 multiplied by 6, and 3 2s and 3 9s. So 9 by 8 answer. So answer is 9 by 8. So let me check. Yes, 9 by 8 answer. Coming to the next one, the area bounded by the two curves and the straight line. It's not only the two curves. X square is these are the two curves which are of the same axis. They have x equals to 0. X square is equals to y by 4, and x square is equals to 9y. X square is equals to 9y. Okay, let me take up, and y is equals to 2. X square is equals to y by 4, and x square is equals to 9y. That's highest value, and therefore one parabola looks like this one, another parabola looks like this one. Therefore it looks, so this is another parabola, and both the parabolas having the same axis actually, and y is equals to 2 is this straight line, and area is nothing but this portion and this portion. And by symmetry, I calculate this area so that you will be getting, make it double, gives us the required answer. And this is nothing but area between y is equals to 0 to y is equals to plus 2. Area with respect to y axis, let me calculate that. That means x equals to something. So therefore, nothing but area is nothing but y equals to 0. Integral 0 to 2. Integral 0 to 2. So from here, x value is equals to, how much in terms of y? X is equals to 3 root y. So 3 root y. Area under this parabola minus area under this parabola, second one. This is the first curve, this is the second curve, and this is the first one, and this is second one. Area under this first curve, that is 3 root y, minus area under this curve half root y into dy. And 3 minus half, I hope will be getting 5 by 2. So 5 by 2 times 0 to 2 root y dy. Yes, of course, 5 by 2, 2 by 3, y root y, limits from 0 to 2. So you'll be getting 5 by 3 times 2 root 2. I think 10 root 2 by 3. So therefore 10 root 2 by 3. Yes, of course. This is a twice of this one area. Total area is equal to twice of it. So therefore 2 times. I'll be getting 2 times, and therefore 2 times and multiply by 2 times. 20 root 2 by 3 is the required answer. So the answer is equal to 20 root 2 by 3 because of symmetry. Yes, correct answer. Next, coming to the area bounded by the curve xy is equals to 4, x-axis, and the lines x equals to 1, x is equals to 3 is given by. Yeah, I hope it is a similar problem we have done twice already. So xy is equals to 4, x equals to 1, x equals to 3. xy is equals to 4, x equals to 1, and x is equals to 3. It is nothing but hyperbola. One curve looks like this, another curve looks like this one. X equals to 1 to x equals to 3, area under this one. Integral 1 to 3 x. From here y is equals to 4 by x dx. And that is equals to 4 times log x, limits from 1 to 3. That is equals to 4 times log 3, and the remaining log 1 is equals to 0. So answer is equals to 4 log 3. It is a B option. Coming to the next one, area bounded by the curve y is equals to 4 root of x minus 1. X lies between 1 comma 3. The domain itself is x greater than or equals to 3. And x-axis and the line x equals to 3. So y is equals to 4 times under root of 1 minus x. X minus 1. X minus 1. So starting from x. So therefore, this is nothing but root x starting from 1. It looks like this one. This is nothing but a semi-parabola. And therefore, this is the value. X equals to 1 to x equals to 3. This is 1 and this is 3. So area under this curve we need to calculate. Okay, from 1 to 3. Therefore, area is equals to integral 1 to 3 y dx. So 4 into root of x minus 1 dx. 4 into root of x minus 1 dx, that is equals to 4 times 2 by 3 multiply by x minus 1 to the power of 2 by 3, limits from 1 to 3. And 3, 1 substitution 0, it's only 3 minus 1, 2. Okay, nothing but 2 root 2. 3 by 2, not 2 by 3. 2 by 3. So 8 by 3 multiply by 2 root 2. So that is equals to 16 times root 2 by 3. So the answer is equals to 16 root 2 by 3, A option. Okay, these are a few sums related with the areas under the curve. Okay, let us proceed to some of the problems on differential equations is concerned now. So to start with, the degree of the differential equation. What is meant by degree? The exponent of the highest order which exists in the given differential equation. This is actually the differential equation in which y dash is called the first order derivative, y double dash is the second order derivative. And its exponent is equals to 4, the answer is equals to 4. So the degree of this differential equation is equals to plus 4. Is equals to 4. Coming to second one, the differential equation obtained by eliminating a comma b from this equation. Eliminating a comma b from this equation. Ax square plus bx. Let me take up ax square plus by square. Ax square plus by square is equals to 1. Let me differentiate. As there are two parameters are there to eliminate a comma b, we need to find the derivative twice. We need to differentiate it twice to eliminate a comma b. Let me take up. This is first order derivative is 2ax plus 2by into y dash is equal 0 and cancellation of 2. And from here, I could able to eliminate a comma b and one from this one. Not eliminating, rewriting this one as this can be written as y dash divided by x can be written as minus a by b. And if you differentiate once again, then a comma b directly will be eliminated. So differentiate both sides with respect to x. This is nothing but x square, x multiplied by the derivative of numerator y double dash minus y dash whole square minus x derivative 1 y dash, that is equal to 0. So constant derivative 0. X square of course gets cancelled and you'll be getting answer xy y double dash minus x into y dash whole square minus y dash is equal to 0. So I think it is y dash is equal to 0. It is the first option. Minus plus, I think it is plus, sorry, it is plus. It is the first option, A. Coming to the next one, eliminating a comma b from this one, we have to get an equation. Of course, it is so simple. When a comma b are, if this is the solution, we can have an equation directly. Y is equals to a e power mx and plus b e power nx plus b e power 3x. You can write down directly the differential equation as there are two parameters. While eliminating, you get answer like this one. Y double dash minus alpha plus beta multiplied by y dash plus alpha beta into y is equal 0, and this is alpha, this is beta. So the given differential equation is minus 2 plus 3 multiplied by y dash plus minus 2 into 3 into y is equal 0. So answer is y double dash minus y dash minus 6y is equal to 0. So the answer is equals to minus 6y minus y dash. I hope answer 6. Yeah, wait a minute. Yeah, minus y dash. Minus y dash means it is option D only correct. Next, 29th. The differential equation obtained by eliminating a comma b in the equation y is equals to a cos omega t plus b sin omega t. Yes, differentiate twice, you'll be getting the required answer y double dash. Y is equals a cos omega t plus b sin omega t. Differentiate once, you'll be getting y dash equals to minus a sin omega t into omega and plus b cos omega t multiplied by omega. Again differentiating twice, minus a cos omega t into omega square and minus b sin omega t multiplied by omega square. Minus omega square taken common, nothing but y you get it. So y double dash plus omega square y is equals to 0. So answer is equals to, so y double dash is equals to minus omega square into y. Coming to the next one, the differential equation of the family of circles with the centers on x-axis is given by. Okay, a family of circles with the centers on x-axis is given by. You can consider the circle equation like x square plus y square plus 2gx. As a center lies on x-axis, y coordinate is 0, so plus constant is equal to 0. So as there are two parameters, you have to differentiate it twice. So you'll be getting second order differential equation. Differentiating once, 2x plus 2y y dash plus 2g is equal to 0. Yes, of course, y 2y. I hope you can differentiate once again directly. You get the required answer. You'll be getting x derivative. First one is 2 plus and 2 times y dash into y dash whole square and 2y multiplied by y double dash equals 0 dividing by 2. You'll be getting y double dash plus y dash whole square plus 1 is equals to 0. So the answer is nothing but y double dash. I think it is a B option. Yes. Coming to the differential equation of the family of the curves, v is equals to y by r, a by r plus b, where a and b are arbitrary constants. To eliminate, you have to differentiate twice. Okay, let me take up. V is equals to a by r plus b. Okay, let me take the derivative. V is equals to a divided by r plus b. Differentiating once with respect to r, you will be getting minus a by r square plus 0. Why don't you bring r square left hand side and differentiate now? You get answer here. R square v dash is equals to minus a. When you find the derivative right hand side, already a will also be eliminated. And keeping r square as it is, v dash derivative v double dash and r derivative 2r multiplied by v dash is equal to 0. Of course, dividing by v, you will be getting, I think, r square v double dash plus 2 by r into v dash is equals to 0. So 2 by r, I hope you'll be getting the C option, dv by dr. d square v by dr square plus 2 by r into v dash is equals to 0. Coming to the next one, the differential equation of all the circles. The differential equation of all the circles which are passing through origin and whose centers lie on y-axis. If you consider general circle, x square plus y square plus 2gx plus 2fy plus c equals 0, center lies on y-axis means g must be 0. Passing through origin means c is equal to 0. So I can take up x square plus y square. G is 0 because center lies on y-axis. So 2fy. Passing through origin means c is also 0. There is only one parameter. To eliminate this one, why can't you divide by y? You can write x square by y plus 2f is equal to 0. Differentiating once, f will be 0. Okay, differentiating once, you'll be getting u by v rule. V multiplied by derivative of numerator minus x square into y dash divided by y square. Okay, plus y dash is equals to 0. And multiplying, you will be getting 2xy is equals to x square minus y square multiplied by dy by dx. Okay, so therefore 2xy is equals x square minus y square into dy by dx. I hope it is the first option. Next, 33. R is equals to 2a by 1 plus cos theta. Yes, of course, theta is the independent variable, r is the dependent variable. You are differentiating r with respect to theta, where a is a constant, 2a. Why not you bring that 1 plus cos theta left hand side and differentiate 2a will be eliminated. So therefore, r is equal to 2a by 1 plus cos theta. Just 1 plus cos theta, bring it left hand side, multiply by r is equal to 2a. Differentiating once, 2a will be eliminated, that will be 0. Here, with respect to theta, you are differentiating. 1 plus cos theta, keep it as it is. R derivative with respect to theta is dr by d theta. And 1 plus cos theta, 1 derivative 0, cos theta derivative minus sin theta multiplied by r is equals to 0. Yes, of course. So from here, dr by d theta is equals to, it is sin theta into r divided by 1 plus cos theta. So 2r divided by r sin theta by 1 plus cos theta, second option. Okay, coming to the next one, ay square is equals to x cube, the differential equation of the family. Differential equation satisfied by the family, ay square is equals to x cube, where yes, of course, a is a parameter. You can divide by a square and you can eliminate it. So ay square is equals to x cube, and therefore a is equals to x cube divided by y square. Differentiating once, you will be getting y to the power of 4, y square multiplied by 3x square minus x cube multiplied by 2y y dash is equals to 0. Denominator anyhow 0, and you can divide by y x square. Dividing by y into x square, therefore we will be getting it. So y multiplied by 3y minus x square cancel, 2x y dash is equal to 0. So 3y is equals to dy by dx equals to 2y by 3y by 2x. Okay, 3y by 2x. So therefore 2x multiplied by dy by dx is equals to 3y. 2x dy by dx. Yeah, 2x into dy by dx equals to 3y. Option is B. Coming to the next one, the degree of the differential equation. Yes, of course. Assuming that, see, as the power exponent is equals to 3 by 2 there, we cannot directly evaluate the degree. So what happens, this particular term, taken it right side, we can write d square y by dx square is equals to minus of 1 plus dy by dx whole square. Yes, dy by dx whole square whole to the power of 3 by 2. Now to eliminate this one, we assume that taken whole square both sides. Okay, 2 gets cancelled so that the fractional powers have been removed. Now in this differential equation, highest order is second order. That is d square y by dx square. That exponent is 2. So the answer for this degree is equals to 2. The answer is 2. Coming to, if m and n are the order and degree of the differential equation, m and n are the order and degree of the differential equation, this one, then m equals how much, n is equals to how much. Clearly you could see that d cube y by dx cube is existing it. d cube y by dx cube is the highest order. Okay, that means it is y triple dash, that is order 3. So definitely order of this differential equation m is equal to 3. And if you take LCM, you will be getting d cube y by dx cube whole square. So n has to be is equals to plus 2. So m is equal to 3, n is equal to 2. The answer is equals to C. So the answer is C. Yes, of course, m equals to 3, n is equals to 2. Coming to the differential equation for which sine inverse x plus sine inverse y is equal to C given by just simple derivative and eliminating C, sine inverse x plus sine inverse y. Sine inverse x plus sine inverse y is equals to constant. Derivative is 1 by root of 1 minus x square, 1 by root of 1 minus y square into dy by dx is equals to 0. If you take LCM, I hope you'll be getting dx. Root of 1 minus y square dx plus root of 1 minus x square into dy is equals to 0. Root of 1 minus y square into x square dy, x square minus y square dx. X square dx, x square dx, I think it is yes, option A. Coming to the next one, the differential equation representing the family of the curves. Y square is equal to 2c multiply by x plus root c. So y square is equal to 2c multiply by x plus root c. You are asked actually where c is a positive parameter is you are asked to find the differential equation represent the family of I think it is okay, it is order and degree. Definitely as a single parameter is there, this is supposed to be of order 1, but order 1 is not there. So we need to check the degree. Is it a 3 or 4? So let us verify that one. Okay, you could define the derivative here. You will be getting it as a 2y y dash is equals to, and it is a 2c. And therefore, c is equals to y dash. By eliminating it, y square is equals to c, nothing but 2y dash multiply by x plus root y into root y dash. Okay, by eliminating this one, you are going to have y multiply by this one. So y is equals to, so you will be getting it as 2x x dash x multiply by, you will be getting y is equals to 2x plus 2 multiply by root y into root y dash. And of course, multiply by y dash. I think it is multiply by y dash. And to eliminate this square root, we have to make it square. So y minus 2x into y dash taken whole square is equals to, you will be getting 4 times of y into y dash whole square, y dash whole cube will be getting. So the degree of this differential equation is equals to 3. So the answer is equals to 3. Degree is equals to 3. Coming to the next one. So 39. The equation of the curve passing through 2 comma 7 by 2. 2 comma 7 by 2 and whose gradient is equals to 1 minus 1 by x square. Whose gradient is 1 minus 1 by x square. Of course, this is a curve. I hope curve is passing through the point means you can just substitute the point and you can verify it. 2 comma 7 by 2. Definitely x is equals to substitution, y you don't be getting a fraction here. Even x equals to 2 you don't be getting, I think it is 7 is not possible to get it. So of course this is the chance xy is equals to x square plus x plus 1, x square plus x plus 1 will be satisfying the answer here. So x square satisfying, the curve is passing through the point. The curve is passing through the point, it's satisfying it. And let me check up the gradient is equals to, yes, of course, none condition is there. Why didn't you check the gradient? 1 minus 1 by x square. You have xy is equals to x square plus x plus 1. xy is equals to x square plus x plus 1. And the gradient dy by dx is equals to x square 1 minus 1 by x square. Why don't you find the derivative here? Y is equals to, it is x plus 1 plus 1 by x dy by dx is equals to 1 minus 1 by x square, exactly satisfying answer. So the answer, by verifying, we can check the answer is equals to B. Coming to the next one, the general solution of x root of 1 minus y square dx plus y root of 1 minus x square dy is equals to 0. Okay, x root of x into root of 1 minus y square dx plus y into root of 1 minus plus y into root of 1 minus x square dy is equals to 0. And it is the solution for this one. Of course, verification is difficult, so better we solve the differential equation here. While solving it, why can't you bring the variables to be separated? Here, as dx is there, why don't you bring x values here, left hand, this term and this term, y variables because of dy. So we divide by root of 1 minus x square, root of 1 minus y square together. Then you would be getting it as x divided by root of 1 minus x square, root 1 minus y square gets cancelled into dx, plus y divided by root of 1 minus y square into dy is equal to 0. Now variables have been separated. Now integrate and replace it by a constant. And this is nothing but minus root of, this is minus c you take up, minus root of 1 minus x square, minus root of 1 minus y square, because this derivative is this one, and minus c. Cancellation of minus c, you would be getting answer is equals to root of 1 minus x square plus root of 1 minus y square is equals to c. So answer is A option. Coming to the next one, the solution of the equation y plus root of 1 minus x square sine inverse x into dy by dx is equal to 0. Same thing. Of course, variables are separable. So y plus under root of 1 minus x square multiplied by sine inverse x into dy by dx is equals to 0. Okay, therefore let me take up this one, because dx is there. Why can't you write down this one? So y is equals to, take y to the right hand side, you'll be getting minus y, and therefore dividing dy divided by y is equals to minus 1 by root of 1 minus x square into sine inverse x multiplied by dx. Variables have been separated and integrating it. Integral dy by y is equals to, it is, sine inverse x derivative is 1 by root of 1 minus x square. It is already existing it. So therefore, I would say that it is a minus integral 1 by x. Yes, 1 by root of 1 minus x square by sine inverse of x into dx plus log c. And clearly you can see that log y is equals to minus logarithm of sine inverse x is equal plus log c. Eliminating logarithm, you'll be getting y plus sine inverse of x is equals to constant. Y plus sine inverse x is equals to constant. So answer is equals to A. Hey, sorry. Yes, of course. We got it correct. I think because of logarithm, when you remove it, log y plus logarithm means nothing but y into sine inverse x. Correct only. I hope my wrong calculation. Here y into sine inverse x is equals to c. Y into sine inverse x is equals to c. Coming to the next one, the solution of the differential equation. I hope it is simple. You can check here by simplification, cross multiplying sine y plus y cos y. Isn't it actually the derivative of y sine y? Derivative y sine y. And definitely option wise, when you verify the derivative of x square log x, so definitely it might be, this is answer y sine y derivative, or this might be the answer y sine y. And let me take up the derivative of x square log x. X square log x is 2x into log x plus log x is 1 by x. I think it is suits answer. Therefore, verification, I could say D is answer. Y sine y is equals x square log x. Y sine y is equals to x square log x plus constant. It is y derivative on both sides. You'll be getting y cos y plus y derivative multiply by sine y multiply by dy by dx. And that is equals to 2x multiply by log x plus log x derivative 1 by x, x. So x taken common, I hope we'll be getting dy by dx is equals to, yes, x multiply by 2 log x plus 1 divided by y cos y plus sine y. Yes, answer is correct. Y cos y minus sine y. So answer is D option. Coming to next one, dy by dx minus y tan x is equals to e power x secant x. Hope this is nothing but linear differential equation, dy by dx. And therefore, this is of the form dy by dx plus py is equals to q. Py is equals to q. So the p is equals to minus tan x. So dy by dx minus y tan x is equals to e power x secant x. E power x secant x. So p is equals to minus tan x. Q is equals to e power x secant x. So integrating factor is equals to e power integral minus tan x into dx. That equals to e power minus logarithm of secant x, and that is equals to cos x. Get it. The solution for this one is y into integrating factor, that is equals to integral q multiply by integrating factor, that is cos x multiply by dx into dx plus constant. So y into cos x equals to integral. Right hand side, this is e power x into secant x. Into cos x will become e power x dx plus c. So y cos x is equals to e power x plus constant. E power x plus constant. Answer is equals to B. Coming to 44. The solution of the differential equation tan y into secant square x dx. So tan y multiply by secant square x dx plus tan x secant square y dy. Tan x into secant square y dy is equals to 0. Since we have dx here, dy here, why don't you divide by tan x tan y, and rewriting this one secant square x divided by tan x multiply by dx plus secant square y divided by tan y multiply by dy is equal 0. Now integrating at both sides, this is integral secant square x divided by tan x multiply by dx plus integral secant square y divided by tan y dy is equals to, I say, log c. And this is f dash by f model, and therefore logarithm of tan x plus logarithm of tan y is equals to log c. Eliminating logarithm, you will be getting tan x multiplied by tan y is equals to c. So the answer for the problem is equals to tan x into tan y is equals to constant. Coming here, the next one, x into dy by dx minus y by root of x square minus y square equals mx square. X multiply by dy by dx minus y divided by root of x square minus y square, and that is equals to mx square. M times x square. Yes, I will rewrite like this one. x multiplied by dy minus y multiplied by dx divided by root of x square minus y square is equals to, it is x square multiplied by dx. Why can't you divide by x square? And simplifying, this can be written as x into dy minus y into dx divided by x square multiply by, and x can be taken common here, 1 divided by root of 1 minus y by x whole square. Yes, 1x. I hope x into x, and you don't have x here, and that is equals to m multiplied by dx. m multiplied by dx. And therefore, I would say that this is in the perfect form. This is in the perfect form. I think it is a differential of y by x. Differential of y by x. Root of 1 minus y by x whole square. Y square by x square is nothing but dy by x and differential. And therefore, now I can rewrite this one as 1 divided by root of 1 minus y by x whole square. It is nothing but in the form of 1 by root of 1 minus x square into differential of y by x. Yes, of course, x square x dy minus y dx is equals to. And I think this one is nothing but m dx. It's nothing but m dx. Of course, when x square, x taken common, one x you can have it taken right side, x dx will come because one x will come here. Yes, now it is integrating both sides, integral plus constant, and this is a sine inverse of y by x, and that is equals to mx square by 2 plus constant. Sine inverse of y by x, mx square, y by x, mx square by 2 plus constant. So answer is equals to B. Coming to next one, dy by dx plus 3 by x into y is equals to 1 by x square, given y equals to x, y equals to 2 and x equals to 1. I think you can find the derivative and you can simplify from option wise, or else you can apply, this is nothing but actually the linear form, dy by dx plus 3 by x into y. Yes, that is equals to 1 by x square. Clearly that when you simplify that 1 comma 2, yes, 1 comma 2 satisfies, I think here in this case, the option B, 1 comma 2, 8 to 2s are 15 and 1 doesn't satisfy the condition here. Y is equals to 2, 2 2s are 4, left hand side, x equals to 1 minus 3 minus 2, first option doesn't satisfy. Second option, when I think y is equals to 2, 2 2s are 4 is equals to 4, satisfying the equation. Whereas here, the third option, when you take up x equals to 1, y equals to 2, 1 plus that doesn't satisfy. And here also, it doesn't satisfy. Answer is a B option. So therefore, x given that the condition, the curve, the x equals to 1, y equals to 2 satisfy the given equation. Therefore, answer is equals to B. The answer is B. Yes, of course. Coming to the next one, the solution of the differential equation. Of course, if you can rewrite this one, it will be easy for me if you can rewrite this one as y by x multiplied by y dash is equals to y square by x square plus phi of y square by x square divided by phi dash of y square by x square. So why can't you take out here y by x is equals to t, we assume that. Okay, y by x is equals to some v. So that y is equals to vx, derivative on both sides when you take up dy by dx is equals to v plus x dv by dx. V plus x dv by dx. So v multiply by, so y by x from the given differential equation, this can be replaced v into dy by dx. So v multiply by dy by dx, v plus x dv by dx. And that is equals to v square plus, it is phi of v square divided by phi dash of v square. And therefore, I hope v square gets cancelled both sides. Vx multiplied by dv by dx is equals to, it is a phi of v square divided by phi dash of v square. Why can't you bring v variables on one side? V multiply by phi dash of v square divided by phi of v square multiply by v dv is equals to dx by x. Multiply 2 on both sides. You can rewrite now. This is integrating on both sides. Integral plus, okay, log c constant when you take up. You can rewrite this one as this is nothing but f dash by f into dv. This is a differential of dv, and therefore logarithm of phi of v square, you get it. Logarithm of phi of v square is equals to 2 times log x plus log c. Eliminating logarithm, phi of v square is equals to, it is cx square. And therefore answer is nothing but phi of y square by x square is equals to cx square is the answer. Cx square, yes, phi of y square by c square, answer is A. Coming to the next one, y double dash minus xy dash plus y plus 4 is equals to 0. I think verification can be done. Y double dash minus xy, y double dash minus xy dash plus y plus 4 plus y plus 4 has to be 0. Let me take up one of the condition, y equals 2x plus 1. Linear form will be easy for me to calculate 2x minus 4. Y is equals to 2x plus 4 when I take up. So y dash is equals to 2 itself. So therefore, and y double dash is 0. So automatically will be getting 0 minus, I think will be getting y dash is 2x plus y. Y is equals to plus 2x plus 4 plus 4 is not equal to 0. So this option is wrong. Whereas y equals to 2x minus 4 when you substitute, y dash is equals to 2, y dash double dash is 0 when you substitute, you will be getting in the equation y double dash is 0 minus x multiplied by y dash means 2 into x plus 2x plus y is equals to plus 2x minus 4 plus 4. Of course, these two cancel, 0, satisfying the equation. So the answer for this one is equals to y is equals to 2x minus 4 is answered. Coming to the next one, general solution of the differential equation under root of 1 minus x square y square dx is equals to y dx plus x dy. Okay, square root of 1 minus x square y square multiplied by dx, that is equals to x dy plus y dx. And I hope this can be written as dx is equals to differential of xy divided by root over 1 minus xy whole square. Variables have been separated, integral plus constant, you can say that. So c plus x is equals to, it is a sine inverse of xy, or sine of x plus c is equals to xy. So x plus c is equals to xy. So the answer is equals to sine of x plus c is equals to xy. Coming to the next one, x square y dy. I hope there is a mistake in the problem. X square y dy plus y dx plus x dy. X square y dy plus y dx plus x dy. Y dx plus x dy. Okay, y dx plus x dy, that is equal to 0. Rewriting, I hope I can write this one as x square y dy plus y dx plus x dy is nothing but differential of xy is equal to 0. Dividing by x square into y square, you can say x square y divided by x square y square into dy plus differential of xy by x square y square, that is equal to 0. Then you can rewrite this one as 1 by y dy plus differential of xy divided by xy whole square is equals to 0. And therefore, integrating it to both sides, you will be getting it as integral 1 by y dy plus integral of 1 by xy whole square into dy is equals to constant. So this is log y minus 1 by xy is equals to constant. So the answer is log y minus 1 by x plus c. Yes, answer is B. C option. Minus 1 by xy, you can change the sign. I hope say both answers are same. I hope so. Because change the constant minus x by y. Yes, of course, log y minus xy. If you change the sign, minus 1 by x. 1 by xy minus log y is equals to c dash. Something like in this way also you can write down. So, of course, the answer is even this one. Both answers are right, but I think there might be mistake here. So, there is answers are correct. Okay, anyhow, enough sums we have done based on the differential equations and the area under the curve. I would like to conclude this lecture now. Thank you.